Oh my goodness, there it is. This is the first time an open source model has actually loaded the game. Wow, so CodeLlama actually beat GPT-4 on this challenge. Unbelievable. It solved it, and not only that, it did it in the most concise way. CodeLlama is out. Meta continues to dominate open source AI with the best open source coding assistant model there is. And apparently it was already instruction tuned and beats GPT-4. Is it true? We're gonna run it through a bunch of tests. We're gonna compare it directly to GPT-4 and we're gonna see if it's better. Let's go. And before we dive into the testing, I wanna show you a couple things. First, let's look at the Meta blog post. Introducing CodeLlama, an AI tool for coding. So CodeLlama is built on top of Llama 2, which was just released a few weeks ago. It's free for both research and commercial use. This is a model that Meta has fine-tuned on top of the LLaMA model specifically for coding. Coding is one of my favorite use cases. And you know what? GPT-4 is my go-to. So if this is better, I'm super excited. And the best part, it's based on a 34 billion parameter model, which means it is possible to fit it on consumer grade hardware. Now, granted, for the 34 billion parameter version, you do need a top of the line GPU, but they also have smaller quantized versions. And here it says they're releasing CodeLlama with 7 billion, 13 billion, and 34 billion parameters respectively. And each of the models is trained with 500 billion tokens of code and code-related data. Now, switching over to the blog post by Find, they have fine-tuned the CodeLlama 34B and CodeLlama 34B Python with an internal Find dataset that achieved 67.6% and 69.5% pass on human eval. And GPT-4 gets 67%. So according to this, yeah, it did beat it, but let's put it through some real world tests to find out. Now, what you're seeing here is two different browser windows. On the left side, I have Find's version of CodeLlama loaded up into RunPod into text generation web UI. And this is the 34 billion parameter version, quantized GPTQ by the bloke. On the right side, GPT-4. Now, for ease of setup, obviously GPT-4 wins. You just log into the website and there you go. However, it's paid, and technically you can get CodeLlama for free on your computer. If you want to see a full tutorial about how to get it installed on your local computer, let me know in the comments. But I've created other videos about how to install those models locally, and it follows the same pattern. Now, a couple things before we dive into the tests. In the model card, I'm using the LLaMA HF model loader, and I'm using 2048 as the max token limit, but I believe you can use 4096 if you want. And I'm setting the temperature to the minimum value 0.01 because this is code and I don't want it to be creative at all. Just give me the straight code. Switching over to the default tab, this is the prompt template. We have a system prompt, a user message, and the assistant. The system prompt I'm using is "You are a helpful coding assistant helping me write optimal Python code." The user message, that's where we're going to put our prompt, and then the assistant, that's what is going to be the output. So let's start testing. The first test we're going to run is the most basic. Write Python code to output numbers 1 to 100. Both models should get this easily. And here we go. Assistant response. Here's a simple one-liner for printing numbers 1 to 100 in Python. Now, this is the first time I've seen it output something like this. Usually it's a very simple iterative for loop, but it's a one-liner. It should work. Let's test it out. Switching over to Visual Studio Code, I paste it in the code and let's play. All right, there it is. Numbers 1 to 100 output perfectly. All right, same question to GPT-4. I have no doubt it's going to get this right. All right, this is usually what I see is that for loop. So let's test it out. I know it's going to work already. Switching back to Visual Studio Code, let's hit play. And there it is. All 100 numbers perfect. They both pass. All right, now the one that basically no open source model gets right on the first try. Write the game Snake in Python using Pygame. And it starts by telling me creating an entire Snake game is quite extensive for this platform, but I can provide you with a basic outline. Now, given I only have 2,000 tokens to work with, I may need to hit continue down here, but we'll see. And you can see it's actually really fast. All right, there it is. It was able to finish within the 2,000 token limit. This script sets up a basic window with a grid where the snake moves around, and the goal is to eat the red square without hitting any part of the snake or the walls. Perfect. All right, let's see if it works now. We're going to copy all this code, switch back to Visual Studio Code. I pasted it. I don't see any errors immediately, so let's see if it works. Push play. Oh my goodness, there it is. This is the first time an open source model has actually loaded the game. So it's it's not perfect because the snake grows indefinitely, and that's not right. Let's see if it ends when I go into the snake itself. Nope. Okay, it doesn't. That's fine. What about the wall? Yep. Okay, so it closes when I go into the wall. I think if I iterated on this prompt a couple more times, it would get it right. So that's super, super impressive. Now let's see what GPT-4 can do. Same prompt, write the game snake in Python using Pygame. Now, looking at the code, it's interesting. It's actually very, very similar. So they set up the colors, they set up the game dimensions, but let's see if it actually works on the first pass. I'm already extremely impressed with LLaMA because no other open source model has gotten the window to even open and work. All right, there, it's done. It's pretty short on code. Let's see if it works. Switching back to Visual Studio Code, I pasted in the new code. Let's click play. All right, there it is. That worked, and it seems to have worked a little bit better already. Yep, the snake grows when it eats, the food disappears, and let's see if it ends if it goes into itself. Yep, it does. Okay, GPT-4 won this time, but still a very impressive showing from LLaMA. Okay, next, I'm going to use this website, pythonprinciples.com. I'm going to grab some of its challenges, I'm going to paste it in word for word into both, then we can actually test the code and see if it works. We're going to start with a beginner problem, capital indexes. Write a function called capital indexes. The function takes a single parameter, which is a string. Your function should return a list of all the indexes in the string that have capital letters. And it gives an example. And let's paste it in. LLaMA, let's go. That looks like it might work. Let's test it. So I copied the code, switching back to Python principles. I'm going to paste it in and we're going to run the code. It worked. Perfect. Same question to GPT-4. All right, let's grab the code. Let's test it out. Congratulations. They both passed. Awesome. Now let's give it a harder problem. This is an intermediate challenge. Define a function named allEqual that takes a list and checks whether all elements in the list are the same. First up, LLaMA. Okay, let's test it out. All right, that passed. This is super impressive so far. Next, let's give it to GPT-4. Same question. All right, I pasted it in. Here we go. Okay, it ran the code and actually it didn't work. So GPT-4 failed this challenge. And it says wrong submission. The call allEqual should return true, but it returned false. Wow. So LLaMA actually beat GPT-4 on this challenge. Let's give it a harder one now. This is the hardest one. Thousands operators, 7 out of 10. Write a function named format number that takes a non-negative number as its only parameter. Your function should convert the number to a string and add commas as a thousands separator. So for example, you give it 1 million and it should return a string that says 1 million with commas. LLaMA, let's go. That looked way too simple. I'm not sure if it's gonna work, but let's see. Unbelievable. It solved it, and not only that, it did it in the most concise way. Amazing. Same question, GPT-4. Okay, so it actually gave me the same exact code, so I know it's gonna work. Yep, there it is, it worked. So they both passed this one. Now, I found another website that has expert level challenges, Edabit. So let's try that one more time. I'm going to give both of them expert level challenges. Okay, longest alternating substring. Given a string of digits, return the longest substring with alternating odd, even, or even odd digits. If two or more substrings have the same length, return the substring that occurs first. Pasted it into LLaMA, let's see. Here's an approach using a sliding window to keep track of the current substring and its properties, alternating even, odd. We iterate over each character in the input string, updating the current substring and checking if it meets our conditions for being the longest so far. Okay, there it is. Paste our code. Error. Not all arguments converted during string formatting. Okay, so that did not work. Let's give the same problem to GPT-4. All right, it's done. Let's test if it works. And check. Nope, didn't work either. So they both failed this test. This was a really hard one. All right, next I'm going to try something a little new. I'm going to say for each model to write Python code that can be refactored as well as the refactored code. Then I'm going to give it to the other model and have it refactor it. So LLaMA first. All right, so here's the original code and here's the refactored code below it. This is great. It follows instructions perfect. First, let's test out the code. 5300. Great. Now let's test out the refactored code, 5300. Perfect. Now over to GPT-4, I'm going to say refactor this code. The given code is already clean and does a specific job. However, if you'd like, we can refactor it by organizing related functions under a class. All right, not exactly what I needed. It's actually longer than what I wanted, but let's test it out and play. 5300. Great. Now GPT-4, I'm going to have it do the same thing. Write a Python code example that can be refactored as well as the refactored code. And there we get the refactored code. So first, let's test it out. Here's the original code, area 50, perimeter 30. And here's the refactored code. Area 50, perimeter 30. Now let's have CodeLlama refactor GPT-4's code. Refactor this code. Now, interestingly, I can't get it to output anything. It just says assistant response. Yep, I can't get it to give me anything. So I'm going to say that's a fail, unfortunately. I wonder what I'm doing wrong here. If you know, let me know in the comments. Also, I'm out of ideas of how to test this against Python. If you have any ideas about how to test these two models with code, let me know in the comments. But that's it for now. I am incredibly impressed with CodeLlama. It held its own against GPT-4 perfectly well. And in fact, on one of the coding challenges, it did better than GPT-4. So this is a huge leap forward. I didn't think GPT-4 was going to have any competition in the coding realm anytime soon from open source. But you know what? I was wrong. If you liked this video, please consider giving me a like and subscribe, and I'll see you in the next one.